Okay, guys, we are just about good to go. I'm going to do the introduction and then I'm going to hand over to Mark as soon as I can find my presentation. I think you guys should be able to see my screen right now. I'm going to do that. I don't know whether it's my face in the video. Okay, so welcome and introduction. My name is Karel Ballack. I'm the president for AREP, and as a non-profit industry body, we have to stay sustainable. So we host events and webinars and conferences because AREP has a lot of exposure to industry. AREP has more than 5,000 members, and we are looking at expanding that. So it's an exciting time. It's a weird time, really, with the market because it seems like the market is retracting. So it's almost as if I know in 2 weeks ago, Hein, in one of the members' meetings, said that the market is just as busy and that 80% of installations are being financed. But what that told me was that the market is actually shrinking. So forgive me, the market that can afford to pay for stuff is shrinking. And with that shrinking comes a lot of pressure on businesses. So AREP has to do what it can to kind of stay sustainable, and hosting these webinars is one of the avenues that we are making use of to be able to provide you guys with what I'd like to think is solid content. Join AREP. For those of you that aren't members, you're welcome to join us on that link. And then if you want to join the WhatsApp group, you're welcome to scan that code or that barcode as well. It's interesting how we have kind of moved forward, but we've not. So I look at these barcodes and I'm thinking, yeah, I'm probably not going to do it because now I have to fumble with my camera and I've got to scan it and then the camera has to read it and oh my goodness. And we'll also drop the link in the chat for joining the WhatsApp group. If you want to host a webinar with AREP, you're welcome to contact Anne. Her details is on that slide. Guys, we are recording this session. I'm not going to be speaking for much longer. I'm going to hand it over to Mark shortly. I think I've got 2 more slides left. This is version 14 of the hybrid test report. So what's interesting is on the meeting that we're planning for the 27th, we are going to be looking at the SSEG test report. We are going to be looking at what has changed in the new part of the standard. And then we are probably also going to have a short clip on the online ECOC. And what we've done with this form is we've taken this form and we've created an electronic version for it, where if you have a Sigenergy inverter, for example, you can say you've got 10 inverters installed and the batteries are integrated, and it changes your form dynamically based on the equipment that you've got on site. So that's exciting. For those of you that aren't interested in the electronic version or the online version, you can access the AREP hybrid test report, and you can download it in PDF or in Excel spreadsheet format. Excel spreadsheet format, of course, you can put your own logo in the form, which is nice. Something that is interesting that we might also be discussing on the 27th is you don't have to submit the form in the format that it's on in the standard. You can choose your own format. So the hybrid test report kind of ticks all the boxes as far as content that's on the SSEG form. So yeah. You've just got to make sure that all the tests that are on the SSEG form is on the test report that you generate. Lastly, then SANS 10142 Part 1 edition. They call it 3.3, but in the form itself, it's actually 3.03. Technical difficulty there because it's not really 3.3. Anyway. Thursday the 27th, 6 o'clock in the evening. We've got a Zoom link there. I see it says meeting, Zoom/meeting/register. So that's going to be one of those engaging chats where you're going to have access to your microphone. Guys, please register for that. Join us. If you won't be able to make it, just register in any case. We are going to make a recording. And the guys who can't join it will be able to get access to the recording. If you have registered, we've got your email address. It's going to be easy for us to send you a link with the recording. So do yourself a favor and just register for that session. Then as far as questions are concerned, I see we've got a couple of notes before we start, Mark. I see Olua Pelumi is here. Olua, welcome. And then Enyina from AWPS Solar Limited, Nigeria. Wow. That's a long way to be joining a meeting, unless, of course, you're based in South Africa. So it seems we might have some guys from other countries in Africa. So if you are not based locally, you're welcome to put in the chat in which area you are. And that should be interesting to see how far the reach for the webinar goes. Cabello says he's in an echo. Yeah, Cabello. Sometimes technology does that. Cabello is logged out and logged back in again. Andres says, good morning. Hi, Andres. Guys, that kind of, I've run through those quickly. I know Mark said that he was going to take questions as we go through the session, but because the microphones are disabled, you're going to have to put up your hands or drop your question in the chat box. And then as we move through, we can have a look at the questions and respond to them accordingly. Okay, Kunle is also here. Kunle, I'm here. And you are there. Welcome, guys. Wynand from Namibia, Lewis from Zimbabwe. So, Mark, it seems we've got a bit of representation from other countries as well. I'm going to hand over to you. You can do your own introduction and then Rudy is from Potchefstroom. That's like a country on its own. Good morning, Rudy. Welcome. Mark, are you there?
I'm here. Morning, Carl.
Excellent. Mark, I'm handing over to you. You've got an exciting product. I love seeing the development of this tool you guys are developing, and yeah, I look at where technology is heading. I'm looking at electricians, and I'm thinking in the back of my mind, if I was an electrician and So one of the guys who couldn't make it today, he sent me a WhatsApp just before the meeting started, said, Carl, I'm sorry, I can't join. I'm busy rewiring a house today. So I'm kind of thinking of that, and then I'm kind of going, but okay, electricians who are in the field, who are busy in the field, they don't always have time to spend on doing design. And I think that's kind of the beauty of what you guys are building and what you are busy with. So I'm going to leave you to it. You can explain to the guys what you guys are busy with and how it can, I don't know. I don't want to say save time, because microwave ovens were created to save us time. Fax machines were replaced by email to save time. Cell phones were created to save time. And it's not like I have more time now than what I had 20 years ago. So your tool is going to make us all a bit more productive, and we'll have some time to do other stuff. Tell us about it.
100%. I just want to confirm, can everybody see my screen?
Yes, we see two guys with hard hats.
Yes. Can everybody see my face?
Yes, you are definitely on the screen. I think some of the other guys, Shekhar also said yes.
Okay, lovely. Well, let's begin. Thank you, Carl, and the AREP team, obviously, for your continued support and for everything that you do to improve the renewable industry in South Africa. And it seems like you said, we have some representation from Southern Africa, and more importantly, from our home country, Namibia. Shout out to Wynand. Hope you're doing well. Wynand and I know each other quite well. And then a hearty good morning to everybody. I'd like to start off with the following. To those who know me, I sincerely apologize. And to those who don't, my name is Mark van Schalkwyk, and I'm the Chief Technical Officer for the SIAAC Group. So as I promised in our brief intro in the AREP members meeting earlier this week, I said I don't want to make it boring, and I don't want to waste everybody's time. All right, it's not going to be a run-of-the-mill. We go through data sheets and show videos. We are showing videos, but it's not going to be boring data that nobody's going to remember. So today I wanted to cover the SigenStack system and why it's considered as one of the best small to very large CNI systems. But to be able to do that effectively, we need to cover some of the basics first. I want to introduce our company, and I want to highlight our technical team and how we handle system design to support our EPCs and installer partners, and then flow from that into the SigenStack system in a way that's non-boring, so that we can continue this discussion offline, right? And prod and poke at the things that were said. From there, I want to provide insights into one of the systems that we use at SIAAC to be able to get your quotes to you in a fast and, more importantly, a technically correct way. And then last but not least, I have to show you Vector, our VR solution, which will definitely help you convert that design system into a signed quote. I really like an open forum discussion, but Carl, I think with we have more than 300 registrants to this webinar. I think we would be here for a couple of days. But we have our lovely Shantae in the chat section, along with our technical supervisor, Francois, who is able and ready to answer all of your burning questions as we go. So just pop that in the Q&A section for us, please. And without further ado, let's begin. So before we can get into the interesting stuff, we need to break down who SIAAC is at its core. This will make more sense when we get to the full circle moment later on. SIAAC was founded in 2016 by a group of renewable energy sector veterans coming from backgrounds such as international EPC, solar panel manufacturing, PPA providers, and supply chain, and so on. We started to expand our reach in Southern Africa, and we now have 9 locations, including Namibia and Zambia. This is all in an effort to support all the regions where our EPC and installer partners operate. The what of what we are is I like to call us a specialist distributor. We aren't a regular distributor in the sense that we stock a wide range of equipment and then sell it as fast as possible, i.e. a stockist, right? We are specialists because we select a product that is not only the highest quality, but that makes sense from a technology background, like Sigenergy. We were the first distributor to import Sigenergy into Africa, and until today, it's the only inverter and battery brand we stock. We currently have 1,800 sites live with Sigenergy, and we've been part of the R&D of this product since its early days as a residential-only offering. I mean, we specialize in this product. We have built all our other offerings like PV module partnerships with Jinko and our own Innosol brand, mounting structures like K2, Schletter, cables from Helu Cable, Himmel, ABB, switchgear. We've built all our other offerings around this, but with the same level of scrutiny. The add-ons and the balance of system items, as we like to call them, need to conform to the same quality as the main equipment that we sell. Part of being a specialist means being involved in many different projects with varying shapes and sizes and design methodologies. And that's why we also offer design support, as we've been around the block with our product and know exactly how to extract the most from our system. To back that expertise, we also offer commissioning support, but we'll get to that part in a minute. So at SIAAC, we're always striving to resolve issues and pain points, and sometimes in very creative ways. Like, a solution doesn't always have to mean a proprietary software like Vector or a physical product like, for example, Starlink. Sometimes it can be as simple as payment terms, customized to your specific project need, or maybe it can be staggered delivery of equipment to reduce your on-site insurance. It can even be as complex as doing an RS-485 to radio frequency conversion because you couldn't get the approval to trench a comms cable in the Kruger National Park. Whatever the case is, we at SIAAC, especially the technical team, we love problems. I mean, we're really good at solving them. We do lead generation as well and distribute leads to eligible installers based on their location and profile. And as I said, we have a dedicated support team. And that's the why. What we absolutely never do and never will do is install, compete with our customers, or share project information. All of the SIAAC top management despise unfair practices, and for that reason, we ask all our customers to either send us an NDA that they're comfortable with or sign one that we already have on hand, so that we can start having more open and honest conversations about their business, their projects, their customers, and how to better support them. So I promised I wouldn't make this boring, and I'm trying to keep the intro super short. So we should be around the 5-minute mark now, so I'm still good. I mean, nobody's yawned yet, but that's because Carl and Anna-Marie muted the mics. So hoping that's the case. Moving on, our technical team. We have 5 dedicated technical engineers. These are a mix between electrical and chemical engineers, generator experts, industrial control specialists, and software developers. We are in the process of appointing 2 more, which would put us with 1 engineer in each branch location. These are the guys that will assist with designs, support, commissioning, and commissioning can sometimes be on site, depending on the project or solution, if a physical presence is needed. But let's be real, with more than 300 people registered for this webinar, if all of you have a site that needs commissioning tomorrow, there's very little chance that it'll be on site. So the general rule is, if we have done it before and it's nothing new, we are confident to support remotely and that the outcome will be successful. If it's a project we assisted with in the design and it's something we've done before, we can 100% confirm that we are confident that nothing will go wrong on site. If it's relatively large and it's your first time commissioning and it's one of those custom situations where we had to do some R&D and back and forth, then we will definitely go to site to ensure that everything runs smoothly and your site's commissioned as fast as possible. So with SIAAC, support is a standard. The only question is, how involved do you want us to be? So we can do absolutely nothing and just send you a quote, but then you might not have the most optimized version of your system and maybe throwing money down the drain. We could be available for questions regarding components, discuss general do's and don'ts, or we could review your equipment list and optimize it based on some information that you're willing to share. I mean, we could do everything or nothing and all the parts in between. It's up to you to decide how involved you need us to be for a specific project, and then we're there. This is purely what you as installer or EPC is comfortable with and what your timelines will allow. So what does that part mean, what your timelines allow? I mean, as technical officer for the group and the technical department head, I sometimes need to review a design or double check sizings and calculations. And I can say for certain that there's no way to just eyeball if the system will work or not without doing the actual math. There are so many variables that need to be considered and angles to prod that if you need to quote your customer today, it won't make sense to request a full scope system design revision with special pricing or terms and a full bill of material. But if we have enough heads up, that's something we definitely could do. That brings me to our approach to system design. This is where things start getting interesting. So from our perspective, and I think this is a given everywhere, we absolutely need to understand the need of the customer above anything else. What is the system for? Savings, stability? Is it for reduced grid reliance? We have to understand the customer's business as well. The geolocation plays a massive role due to factors like wind loads, temperatures, for panel coefficiency calculations, and then municipal and utility tariff structures. I mean, local regulations as well, the list goes on and on. But we need to deeply understand the nature of the business. What is it that they do? Is it an office, a manufacturing plant, maybe a farm or hospital? And all of this will give us insight into things like grounding system, for example. This ties into their operating times as well. Do they operate between 8 to 5 or 24/7? All of this is part of a discussion that happens between the installer and the customer. And many times, as distributors, we aren't privy to this conversation. So that's where that open communication based off of our NDA agreements comes from. We need to be able to access some of that information to be able to properly support you. But after that baseline information is determined, and then we can move on to the data, whether it's data loggers, municipal bills, site load audits, or even I know some electricians that even do a clamp meter and drop the mains and switch everything back on, you know. However it is presented to us, it's crucial to have data. We need insights like resistive loads, inductive loads, what the split is, the lowest power factor readings, etc., etc. So again, we know our system front to back, but it can be very, very easy to underspec a system and have constant issues, or to overspec a system because you aren't sure of your data, and then you just end up outpricing yourself against your competitors. We have developed our own in-house systems. As I said, we have in-house software engineers. So we develop our own systems to be able to design correctly and consider all factors relatively quickly, as we sometimes need to deal with many requests at a time and need to be as technically correct as possible while also being fast. We'll be looking at some of them in the next couple of slides. For our example today, we received hourly data from the installer, and we'll be looking at one of our engineers sizing the system for a 4-hour backup with the ability to arbitrage. We were informed that there's a 450 kVA generator on site, and the site has heavy inductive loads with a lot of pumps. Here we see him passing the data from the customer. He isolates active and reactive power and then verifies the data validity. He then transferred it to our in-house sizing sheet, and we'll start to specify the parameters for the specific project. This is the part of the system where we specify, is it for backup or arbitrage? How many hours of backup? What are we replenishing the batteries with? Is it grid or PV? For this specific case, the site requirement was for 4 hours of backup. And since the grid is unreliable in the area and they face multiple outages a week for indefinite times. So he's now specifying the 4-hour requirement, and we already have the active power pulled through from the customer data table. We can see that the minimum measurements at about 50 kilowatt average, the average is at 77, sorry, and the max is at 108. But remember now, this is only the active power. We will get to the reactive calculations in a second. As there is a generator on site, we need to determine at what SOC we need the gen to start and factor this into the calculation. We already received this info from the installer, and they said they would like to discharge to about 10%. And wapa, you see, blue section, from the supplied information, our sheet has provided a base to work from, specifying the batteries at around 600 kilowatt hours, but this still needs a bit of work. Our engineer now further tweaks the values while ensuring this makes sense within the parameters that were given to us. We don't solely rely on our tools. We also cross-check and test all values to ensure that it's technically correct, and more importantly, that it aligns with the customer's need. You will see him testing the tool by purposefully inputting a smaller generator size, and you will see that the gen then fails to meet the criteria set in the battery replenishment area. He then changes it back to the actual values and cross-check, and then it passes. Right there, gen overload. Back to 450, generator pass. So we usually size the generator at duty of about 75%. That's a general rule of thumb. He then continues to change the peak sun hours for this area based on multiple data sources and the average values for winter. Why do we use winter? Because this would be the worst case scenario that the system would need to endure multiple times during its lifetime. The panel efficiency factor is derived from the fact that no solar panel can produce its nameplate output, even if it's brand new out of the box. There are so many things that influence a solar panel's production, like angle of incidence, azimuth, soiling, temperature. So again, we're using a value of 85% to account for all of these as the start of our design. In this case, we will need to arbitrage twice when grid is available, and ideally, we want to recharge with PV as much as possible. At this point, we need to determine what I like to call first pass and second pass PV calculation. The first pass only covers the load as close as possible during the usable sun hours, and then the second pass calculation incorporates what's required to replenish the batteries during that time. These are then summated and verified. This gives us a clear indication of the total PV required. Our engineer can now check what power class and technology panels are available and then spec them accordingly. I would like to... Yes.
Sorry, just for the benefit of the guys, because I know a lot of them are working and they're kind of taking calls and trying to navigate life as it is in between the presentation. The Excel spreadsheet, just quickly, the Excel spreadsheet that you've got open now,
yes.
Is this spreadsheet shared with guys that are interested in, because this contains the information you guys need in order to design a site, right?
Correct. We could share this spreadsheet. We have shared it in the past. This is mainly for use for internal use, but I mean, we could modify a version of it for anybody that requires it.
Okay, that's fine. I'm just trying to give some of the guys a little bit, because now if you've taken a call and you come back and you see the spreadsheet, all of a sudden, what are you looking at?
I see. No problem. I think
Thanks.
we can upload the video to YouTube and then rack up some views. Maybe we can do some monetization.
Yeah, that'd be good. I'm going to mute again and you can carry on. Thanks.
No problem. All right, so where are we? Okay, so I think this is where the fun begins. That's correct. All right, so we saw that the tool gave us an inverter size of 300 kilowatts, but we know that the site has multiple pumps and we need to look at inductive load. So just as a little gold nugget of information, the SigenStack system can handle 60% of its nameplate in inductive loads while off-grid, okay? While on-grid, there's what we call a pass-through that will allow up to 150% of its nameplate if the gateway is appropriately sized. So in this section now, we see him taking sorry, let me just restart it. Apologies. Just get back there. There. Exactly there we see just give it a second. I apologize for that mishap. There we can see him taking so he essentially took the maximum kVAR measured and dividing it into the inverter size to determine if we exceed that 60% threshold or not. The required inverter size came out to be 265 kilowatt to be able to start the pumps during a grid outage. So our tool's 300 kilowatt designation seems perfectly fine. Our engineer can now start drawing up the bill of material, as you can see, for the main system components and check if we can optimize the offering to lower the cost. There are, with SigenStack, many optimizations that we can do to lower the initial cost, which most people aren't aware of. From here, we can start with the site layout, which is one of my personal favorites, but also where most of the time is spent, and you will see why in a second. For this exact example, we received a photo of a site layout. Our engineer's first steps would be to pick a known length on this drawing and then recreate a line of that exact length and then scale the drawing itself until the lines are equal. This forms the proper starting blocks for a scale drawing design. He would then go and draw in the walls and floors, as you'll see in a minute, and then start creating a rough recreation of the site. This design was sped up by 10x, just so that you know we aren't really that super fast. This is about 4 to 5 hours of work. There are many ways to do this, but the most efficient and most effective way that I've found is to scan or recreate your site using our vector technology. This, however, does require you to be on site, whereas in this instant, we couldn't be on site physically and had to create the site this way. We will see him start to add more and more detail now, and I know many of you have been thinking, but why? You know, a flat drawing will absolutely do the trick. Yes, I agree, it does, and it has for so many years. But designing in 3D adds that obvious third dimension, which is height. Right? I can't say how many times the site plan had to be changed because someone didn't factor in the cable gantries in the roof or check the actual height of the concrete slab above. Yeah, the third dimension is valuable in all cases. We also add as much detail as possible because it makes decision-making easier when we can see the full picture. Like which ways doors open, the height of the door. Would we be able to get a gateway into that inverter room? You might think it's stupid, but yes, it's happened before, and we had to break a hole in the wall and the floor to get the gateway. Okay. Also, detail gives the customer a great reference point when we show them the design later. they're able to start from a familiar place and then see what can be before it is. And this starts the sales conversation on the right note, and it shows that your attention to detail is up there when it comes to their offer. I think this video would have been great with some background music, like a pan flutes or something, you know, just something calming. So I just paused it. He added generators and DBs, placeholders for the DBs, and then he started adding the inverters and battery systems of the SigenStack. We can see the 300 kilowatt gateway over there, and this is all just a rough plot out. Okay. As I said before, we design many of our own tools in-house because we don't like waiting for software companies to change the tools based on our requirement at that time. And then normally if you use somebody else's software, you are stuck bending your solution around what the software offering can give. And we would like to bend the tool to the solution that's required instead of the other way around. So here you can see one of our tools being used as well. It's a interactive cable generation system. This cable generation system is able to very accurately measure cable lengths and bill of material for cable trays, right? So all the sections, the T's, the bends, everything is then counted and designated on a separate bill of material. So we can see it took some iterations to get that cable to a place where he liked it. And then I think we'll see that again in a second.
Mark?
Yes?
Sorry, just another quick question. It sounded like you just said that the cable tool is a separate tool, or that's how I heard it.
The cable tool is a custom tool that we've designed inside the platform that we work.
Okay, so it's not like we can use the tool to do the cable work outside of, so we kind of just, we're interested in just using the cable tool. It doesn't work that way. It's got to be part of your complete solution.
Yeah, so there's a few different parts. So we currently do all our PC-based design on the SketchUp engine, right? And SketchUp allows you to code your own tools and plugins. So that's why we like it, because it's so easy to use and easy to manipulate to what we need.
Yes.
Okay. So we could definitely make our plugins available to people who need them and who actively use that same platform. But yeah, the VR solution with that cable system, unfortunately, that's locked and hard coded into our own app on the headset. So there's no way to extract just that section. You would need to use it with the full offering. Okay.
No, that's cool. It just sounded like it could have been a separate tool, so I was just curious.
It could, depending on what the need is.
Okay. Thanks.
So we'll see him testing a few different cable runs and checking pros and cons of all of them as he goes. See, verifying position. And eventually he will settle on one that makes sense for installation, makes sense for bill of material, makes sense cost-wise, and also serviceability afterwards. So we do not just think about the visual, we also think about the sale, how it impacts, and then also your ability to service the site within 10 years from now. You can see he faced a few errors there and finally settled on a cable path, which I think looks great. He's now doing some battery cables, but this is purely for aesthetics. This will be negated from the final bill of material. This is purely that when we show the customer this design, that they don't ask why isn't there any cables connected to the batteries. Again, same with the generator cable as well. Plays around with a few cable parts, what makes sense, what doesn't, orientations of the tray, but these generator cables, as the generators existing on site, these will also be taken out of the bill of material for the final quotation. This is purely aesthetics for when we show the design later. The next tool is one of my favorite, also a custom one. This gives us the ability to select an enclosure, right, or to specify string quantity. Let me just pause it quickly. This is actually super cool. Oh my goodness. I'm very unhandy with this scrubbing bar today. Sorry. Okay, there we go. So this specific tool, based on parameters that he inputs, string information, voltages, etc., this tool is able to select a DC enclosure and then pre-populate and wire the DC enclosure and then add all of that to the bill of materials. And you'll see, just out of interest sake, there's a little section over there called fire suppression. We've recently tested DIN rail fire suppression as well, because as we all know, the Sigenergy system has built-in fire suppression in the batteries. It's got AFCI and GFCI controlled by AI that's able to detect arcs 500 meters downstream of your installation, and it will switch itself off from an AC perspective if it picks up any irregularities or loose connections. The only point that the SIG system cannot stop is the actual production of the panel. If the sun is shining, the panel will produce. And for that reason, we have sought to start looking at DIN rail fire suppression for our DC combiner boxes. For those of you who do not know, we are also able to design, assemble, and pre-wire DC combiner boxes in-house, which we then spec for specific projects as this one, and then we can deliver to site. We've tested this many times with our EPC partners, and all of the feedback is that it saves so much time on site having a quality box that's pre-wired that you can just plug your strings into. Right, pressing play, and voila, 6-string box pre-configured, all spacing, and it's got the added DIN rail fire suppression. So for now, he will start doing the PV cable runs so that we can get that onto the bill of material. So firstly, he starts off with the runs between the inverter and the DC combiner. And then double checking the bill of materials. All right, moving on to the PV array. So the rough location where the array is supposed to be installed is measured out, placed, and we'll look at the angle in a second. Using the software, we can simulate shadows at any time of day, at any time of the year. So we like to use this to look at self-shading and to see whether specific array distances from each other will cause self-shading at any point during the day. So during usable sun hours, which is normally between 9 or 10 in the morning to about 3 or 4 in the afternoon, we'd like to see that there aren't any shadows being cast on the panels behind, so that we don't limit production. The engineer will then go on to to start drawing out the PV cables for the PV array, to add all of those measurements to the bill of material. Obviously, this needs to be in some sort of a sleeve or in piping underground, but we add a 10% safety factor on our bill of material calculator for all PV cable for that instance. Running into some issues. Needs to rethink a strategy. All right. I'm going to start chatting about the next tool because it's going to fly by so fast at 10x speed. So we've also developed a volume calculator to determine the actual volume of the inverter and battery room, and to calculate the level of heat generation at a specific load, and then to calculate the BTU hours required to keep the room at a certain temperature. Right? This calculation is then an N+1 type, which then adds extra redundancy should one air conditioner fail. And as you'll see in a second, the system will then spit out an airflow simulation, which shows a good coverage of the entire area with that specific configuration. There we go, room volume. And we can see we've got free-flowing air all in between and throughout the entire volume, which is good. Double-checking design, top side views, and that brings us to the end of how we approach site layouts. Do we have any questions on that part so far? Francois, are we good in the chat?
We have a lot of questions, but I'm not supposed to.
Really?
Yeah.
I can hear your keyboard's on fire. Okay. So, I mean, how cool was that? I could watch that all day. Just add a pan flute to the back of that and put me on a hammock. Moving into why we chose to specialize with Sigenergy and specifically push the SigenStack system. As a business competing with many other brands in an already saturated market, we are constantly benchmarking to see where we stack up against our competition. No pun intended. When we introduce Sigenergy to people, we usually get met with some of the following. Sig is expensive. Yes, it is a very premium product. And if you compare line items on a quote, it will seem more expensive. But almost always, looking at the total system cost, Sigenergy works out more cost effective, especially when we are involved in the optimization process. We have to remember that Sig installs lightning fast and commissions in minutes. I mean, we have a 20 megawatt hour plant in Bulgaria that was done with SigenStack, and that was installed and commissioned in 7 days. So this is obviously without PV, but that's an insane amount of time. Well, that's an insane short amount of time. Another one of the misconceptions that we get is that a larger inverter and battery is more reliable. Why? Just because it's bigger. We strongly disagree with that fact. In fact, the smaller modular units allow for added redundancy because the Sigen system is able to bypass faulty batteries and inverters automatically and then redistribute loads among the remaining units without dropping the load. When we design, we keep that level of redundancy in mind. We designed a lodge for one of our EPC partners in Namibia, and to get access to this lodge, I mean, if something happens in the middle of the night, the O&M team needs to drive for at least 4 hours. I mean, and when the power goes down, the internet's down. So they have no visibility into their system. So they end up driving, pulling a trailer with a bunch of spare batteries, BMSs, inverters, etc. and whatnot in the middle of the night, essentially going blind. We designed that replacement system with Sigenergy and with redundancy in mind they can now lose 45% of their inverter capacity without losing power to the plant. That means, and that's obviously a disastrous situation to be in, because we will know when the first unit does fail. They rarely ever do, but if it does, then we will know about it, and they have about 2 weeks, 2 to 3 weeks to solve the issue without affecting the side output. We hear that SIG can't scale. I mean, we just spoke about 20 megawatt hours in Bulgaria. We have our own, a few of our own 5 megawatt hour sites live right now. We've got a 6.4 megawatt hour in Namibia. I know Vainant in the comments has a few megawatt hour sites live with SigenStack as well. This exact technology, I mean, it beats all other competitors in price. And in one instance, the Sagen system even replaced the competitor system, which was up and running. The misconception that it's more work to install or it's more complicated is it's like building Legos, and commissioning is so smooth due to the intranet network that Sagen creates to communicate between its devices, and it can share firmware between units. It's literally the smartest system that you can ever work with. We sometimes hear that our preferred brand software is better. Okay, we constantly test the MySigen app versus the others, and the MySigen app is leaps above the rest on the market. The new Sigen AI agent can predict loads and make system decisions based on your past load data during the same weather conditions. How many times do you have to go back to sites to readjust time of use settings when the tariffs change between high season and low season? If you know, you know. We very often hear it's a Chinese brand and that it can't be trusted. I mean, I hate to break it to you, but almost all the brands on the market are Chinese. But this specific brand comes from the minds of the best engineers and innovators in the renewable energy game ever. Tony Zhu and his team have more than 30 years of experience between them, and they created a top-notch product. And there's a very good reason why it's #1 in almost all the countries in the world. The Sigen batteries, I mean, they can cycle down to 100% DOD under warranty and still last 10,000 cycles. This slide speaks for itself. As I said, we constantly benchmark, we constantly look and poke and try and poke holes into our arguments. Our salespeople already know. When the whistle blows, everybody needs to line up for an argument session. Why, how, what? And the answer always comes back as the same. Outdoor protection, IP66. Battery level fire protection, right? So a few of the other vendors also have that, right? But it's applied at an individual module level, not as a battery pack as a whole. Battery expansion, small 12 kilowatt hour packs. Other vendors have larger packs, larger increments, which almost always lead up to, if my customer only needs 50 kilowatt extra, why do I have to add a much larger battery? With the smaller Sigen systems, we can even mix and match battery sizes to get to an exact system size or battery size. Module level redundancy, almost none of our competitors have that. Our failure impact is 12 kilowatt hours. If one battery fails, you only lose 12 kilowatt hours. With most of the others, you lose a much larger chunk of your installed storage. We have 0 millisecond changeover, true 0 millisecond changeover. I mean, this does not disrupt the load side. All other offers on the market are 10 milliseconds plus. We've got parallel scalability. We can scale and parallel up to 100 units. There are larger solutions for these types of scenarios, but if your site ever needs to grow into 100 units in parallel, you definitely can. We have PV and BESS architecture, right? Our system is a native DC coupled system. That means the PV and the batteries are connected. Okay, it's direct DC-DC for charging, and the only DC to AC conversion is during the discharging process. We've got pack level optimization with DC-DC optimizers, which none of our competitors have as well. So stacking the system side by side, as I said, the slide speaks for itself. We are more than willing to enter into any conversations offline regarding these. We are more than willing to have the view of everyone in the industry. Obviously, we aren't experts in all the brands, but we would like to hear the view of some of the installers who are used to the other systems. On the warranty side, SIG offers a 10-year replacement warranty. Some of the other vendors do as well, but then we need to look at the fine print and see if it's a repair warranty or if it's a replacement warranty. We've got integrated AI management, right? Which optimizes the load. Like the new MySigen app version 4.0, as I said, if it can check on a sunny day that your system load spiked because you might have switched on the air cons, and then it can proactively look at the weather forecast and plan its battery discharge or charge based on the upcoming load. It can anticipate these kinds of things. Monitoring platform. We've got the MySigen Plus AI. It's a fully integrated ecosystem. The battery was designed with the inverter in mind. The inverter was designed with the battery in mind, and the software with both of those in mind. It's not like you have a battery and inverter solution separate, and you need to plug in a third-party EMS or a rebranded dongle. And now you go through some other platform to be able to view your system, which is almost constantly off. All of this was designed with everything in mind as a total solution. I mean, remote software updates. Everybody has that. It's a requirement. Installation. Because of the modularity of the SIG system, you can easily get it into nooks and crannies and through small holes. You don't need a crane. You don't need extra trucks on site. You can get to the exact size that you need with the Sigen system. Almost to the exact size on the AC and on the storage. Module replacement is plug and play. I mean, take, for example, the 300 kilowatt site in Namibia. If one of those inverters should fail and a replacement is needed, the O&M team simply needs to drop the breaker inside of the gateway and disconnect the DC. And then they can hot swap that inverter. And as soon as it gets switched on again, it's a 5-minute process. Plug out, plug in, switch on. As soon as it gets switched on, the firmware can be shared from its neighbor system or its neighbor stack onto that unit. And all you have to do is scan the QR code with your app. It's as easy as that. We have a verified 100% depth of discharge, which some of our other competitors also have. But again, overall winner is SIG. So after our design was completed by the engineer, the bill of materials would be sent to a sales representative to start structuring the quotation. As I've mentioned many times, we have a lot of tools that we create in-house to fact check and verify for us. In many instances, a design or an EPC does not require the full design scope. It merely needs a bill of material and a quotation as fast as possible. For this, I'll introduce our SigenStack configurator system. So you'll see the user put in EPC details and some project detail, and the best installer, yes. I just wait for the installer name, the contact name.
Mark, I'm just doing a quick time check. It is 12 o'clock at the moment.
Yeah,
there might be some guys who have other. Yeah, there might be some guys. I don't mind as long as there's value. It's great, but you might find that there are guys who might have other commitments. Yeah, it's
no problem. We almost done.
But you can run through. You can run through.
Sure. Thank you. All right. So essentially what this SigenStack configurator does is it allows the salesperson to enter basic information that the EPC shares with them and spits out a BOM, right? But this BOM is then checked against all of our pre-programmed engineering checks. So as soon as we start looking at site requirements and he starts putting in what the incoming supply size is, generator size, the measured load from the customer data, the arbitrage and backup options, you will see that some system warnings start popping up. These warnings were integrated into the system to help a salesperson understand and better communicate to the EPCs about what the potential risks are with the specific configuration. It's also there to highlight the need for a technical engineer to once over this design. For our specific demonstration today, Francois already looked at the design, and that's where we got the inputs from. So we will be ignoring the system warnings in this one. This helps us to quote much faster, but also get the needed handbrake when things get hairy. It's usually at this point when the branch engineer would be involved, as I said, but it's, you know, it's a good indicator for our salespeople to get back to you as installer and double check that these things have been considered from your side as well. As you can see, we at all times want to be absolutely sure that systems sold by us will perform as intended. Now for the cake at the end of the meeting, my personal favorite and where I like to spend most of my free time is Vector. I know most people have only been enduring my voice because of that. Okay, so this is a sneak peek of our new graphics engine, but for those who don't know, Vector is our very own virtual reality design tool. And for this example, we'll load the design that Francois designed inside of Vector. You are capable of scanning and recreating any site and build a system using our pre-programmed models. I'm just gonna let this play. Right. So the models that we have in Vector were pre-programmed, so they know exactly what they're allowed to do and what they're not allowed to do. They know what clearances they should maintain. They know what cable connection they have and what should be connected for the system to be functional. We have a separate part inside of Vector called the workroom, where you can create pre-assembled units and save them for later use, like, for example, AC or DC combiner box. If you select an enclosure and the switchgear that's needed and you snap it onto the rail, wire everything up, then you can use that combiner box for many different projects without redoing all the work. We have a cable system that can count cable length, similar to the tool that we use for the SketchUp engine. It can count cable lengths as you draw them out. It's very intuitive, and it knows what it's connected to, either an AC or a DC terminal. And get this, it'll also do the volt drop and impedance calculations on the fly, which can then auto adjust the cable size and its type as is required. We have nuts and bolts bill of material that's built in. That's similar to what we've seen in the previous slides, but we can count exactly what's required, from fasteners to lugs, even the length of heat shrink that's needed. It lists all the tools that's needed for specific things in your design, and it's also able to generate SLDs and technical drawings. This is obviously a very large undertaking, even for more established software companies, but we have managed to get to this point in just little over 1 year. This is, however, a constant development. We are currently testing the co-location feature, which allows our engineers to be on site with you as an avatar, and they can hear and see you and assist you with your design. tests were successful, and we will be implementing that into the next build. The new graphics engine now allows us to add dynamic lighting and reflections to better drive home the customer experience when they see their future system in a one-to-one scale in their environment. We have a beta testing program that will start shortly to better plan our commercial rollout. But for now, the best way to access and benefit Vector is through one of our branches. Each branch engineer is equipped with a headset and is able to retrofit an existing design or design one from scratch inside of the headset. For all of our registered customers, we are also able to send you a headset for the initial site measurements. We can then extract that data and rework it and then send it back to you over the air. This is obviously next level tech and requires some next level thinking, but it also comes with thousands of challenges that we constantly have to solve. So our timelines sometimes need to be pushed based on what new challenge we are facing. But please reach out if you need Vector assistance to convert a potential deal or customer. Here we can see everything that Francois did on the previous video. It's fairly smooth, actually. See, now viewing it in VR, I think we might need to move that cable tray a little bit more to the corner, or have it bend directly out of the hole to the left. But that's the thing. And what's cool is you can also walk through walls and just look at those cables. Cable management, perfect. So, Carl, to answer your question, yes, I think this tool will save us some time, not like the fax machine and the telephone. It's just made the world much smaller than it needs to be. Just showcasing the fact that we can also scale down the design and present it on a boardroom table. We can also, while we're on site, have a smaller version of the site, remove the roof, etc., and start moving things in real time. The ability for Vector to change the design on the fly is really, really cool. So as I said, you can output technical drawings and SLDs from this, but if we need to change something on site, move a cable tray, move an inverter stack, or add something, everything that's outputted from it will update automatically. So when we get back to the office, you don't have to go and redo drawings or remember what was said. And that, folks, brings us to the end of my long story. I hope it wasn't too boring and that we have added some value to your Thursday. If you are interested in any of the items we've discussed or to learn any more from SIAAC, please scan the QR code on your screen and then fill out the form, and one of our expert team members will reach out to you. I think we can open the floor to some Q&A if anybody is still in the webinar. Also, feel free to get our contact details if you want to ask something offline or if you think of a question later. That's it. Thank you, Carl.
Us to the end of this session. Thank you very much for joining us. Wow, lots of interesting information that's been shared. I did see that there was someone who said that they were Sven said that you guys were also interested in all the inverter and battery backup systems that were available at the beginning of the COVID period. Maybe what you could do is let us know what info you're looking for, and we can host other webinars with that kind of information and make sure that we cover other types of technology. Mark, I think what you guys have done here is stellar, and it will definitely save time, I think, especially from a making mistakes on site point of view. and trying to figure out things before you get to site to make sure that you've actually got the right equipment and you've made provision for everything in the design. Thank you very much. I did note that, or I see that there's in my chat box 11 more questions, but I'm kind of hoping those were guys saying thank you and we are logging off. It looks like those are all the questions have been sorted. In the Q&A, where's the Q&A? Oh, there. But the guys are busy working through them. I see I've created a bit of a stir. I asked a question that I maybe shouldn't have asked, and that was about the calculation sheet. I think Rudy asks for the presentation. Yes, Rudy, the recording and the presentation will be available. Assist with grid integration. I'm assuming that would be a webinar on grid integration. Louis says continued concern on other vendor installations and hardware versions, replacing parts versus fast software changes. Oh, yeah. Mark, I'm just going through the questions quickly.
I'm reading them as you go.
Dave wants to know how long will a design take?
Depending, full bill of material, full scope. Full scope could take anything from 2 days to a week. But let's say, to be safe, depending on the project size, of course, anything from 2 days to 2 weeks. But that's still much faster than some EPCs we know of. I think the standard for technical drawings and system design verification is about a month to 2 months for larger systems. So our systems definitely do speed up the process a lot.
There was someone. So Ulebo Geng wanted to know about the grid integration. And now that I think about it, maybe that also covers things like energy management systems. But we'll see what we can do with those. So grid integration will be on existing systems and how you connect them to the grid and how you integrate that with other electrical sources on your site, like generators and loads and that kind of thing. How do you switch stuff on and switch stuff off? Guys, I think that brings us to the end of this session. It is 20 past 12. Mark, it's substantially longer than what I anticipated it to be. So for those of you that have missed other meetings or missed part of this session, I apologize, but it will be available as a recording. Thank you very much for joining the session. I hope you've had some valuable information and useful and interesting info that you've learned from Mark and how they do things. Mark, thank you very much to you and your team for running through the questions. It feels like there have been hundreds of them. So yeah, it's been an amazing session. Thank you very much. Unless there's anything else, Mark, you want to add, thanks to Anne for organizing it. Thanks to the SIAAC team for the support. And I think that brings us to the end of the session. Mark, any last words?
Yes. I forgot to mention that every SIAAC branch hosts in-branch training session on various topics every 2 weeks. Feel free to pop by or chat to your nearest branch to find out when the next session is. Pop by. We usually have a braai and a drink on that day after the training. So pop by, have a listen, grab something to eat, and then feel free to ask anything that you need to ask. That's it from me. Thank you so much.
Excellent. Guys, thank you very much. And that's it from me as well. That's a wrap. Thanks, guys. Thanks, Anne.